Hi students, today we discuss the new topic mechanical properties of fluids. Okay, in this topic we study the properties of fluids, and first we discuss what is meant by fluid and then the properties of that fluid. Okay, first what is meant by fluid? The fluid is a substance which can flow. Okay, that is, you know that water is a fluid, also air is a fluid because they can flow. Therefore any substance which can flow is known as fluid. Okay, but for ideal fluid gases cannot be considered as ideal fluid. Therefore we careful about what is the properties of ideal fluids. The main two properties of ideal fluid is they must be incompressible and also they are non-viscous. What is mean by incompressible? When you apply a pressure on that fluid, the volume of that fluid cannot be changed. That is, during the application of pressure, the volume is remain constant, therefore density is also remain constant. This is not applicable for gases. Hence, liquid or water can be considered as ideal fluid. Okay, also they are non-viscous. Non-viscous means when the fluid is in motion, then there is no friction between two relative layers of the fluid. Okay, that is, in solid we know that when one surface of solid is slide with other, then there is a friction, but in case of liquid there is no friction. Also they have irrotational. Okay, then there are three main parts in this topic. The first part is fluid is at rest, the second part is fluid is in motion, and the third part is the surface tension. Okay, here we have to discuss the first part, that is fluid is at rest. That branch is called as hydrostatics. Okay, the main properties of that fluid is at rest is the pressure. Then first we explain what is mean by pressure. Pressure measures the effect of force. Okay, we know that when you carry a 10 kg bag, okay, and if the handle of that bag is wider and if there is a string, then it is very difficult to carry that 10 kg bag with a string attached to that bag. Okay, and it is very easy if the handle of that bag is wider. That is, suppose a foam is attached to that bag, then it is very easy. Also you know that when you press, suppose this is the chalk, when you press this chalk to hand, okay, it cannot emerges out. But when you apply the same force on that needle, the needle emerges in that in our body skin. Okay, therefore if the area is small, the effect of force is large. That is, the effect of force is mainly depend or it is measured by pressure. What is the definition of pressure? The pressure is defined as a normal force acting per unit area by the fluid at rest is known as pressure. Okay, in fluid, if this is a fluid at rest, then this fluid exert a force on the walls of the container. Here, in this side, in downward side, this force is always perpendicular to the surface. Okay, and that perpendicular force per unit area is called as pressure. Okay, therefore pressure is the perpendicular force per unit area. Its SI unit is Newton per meter square. It is also known as Pascal in the honor of scientist Pascal. Okay, practical units of pressure. There are 2 or 3 units which can be used to measure pressure. The first unit is atmospheric pressure. You can measure the pressure in terms of atmospheric pressure, and that pressure is 76 centimeter pressure of Hg column or 760 millimeter of Hg. Hg means mercury, and its value is about 1.013 into 10 raised to 5 Newton per meter square. Okay, here also 1 bar barometric pressure is equal to 10 raised to 5 Newton per meter square. 1 bar is approximately equal to 1 atmospheric pressure, and 1 Torricelli's. Okay, Torricelli's also is the name given to the honor of the scientist Torricelli. 1 torr is equal to 1 millimeter of Hg. Okay, therefore 1 atmospheric pressure is equal to 760 torricell. Okay, these are the some units, practical units we used in measurement of pressure. Now we have to study how the pressure is measured, how pressure is exerted due to a liquid column. We know that when you swim below the liquid surface, okay, or in the tank, then as you go down and down, the pressure on your body is increases. Okay, that is, if you go depth very down, then the pressure is increases. That is, the pressure is depend on height of liquid column which is present above your body. Okay, to calculate pressure due to a liquid column, I will draw here a figure. In this figure, this is a container, and in that container the fluid is filled. Also, I can consider an imaginary cylinder. I want to find the pressure at point N and pressure at point M. What is the pressure at point N and M? Okay, here this is the cylinder, imaginary cylinder, and A is the cross-sectional area of that cylinder, H is the height of that cylinder. We know that on this area, the pressure above this, the liquid which is present above this surface area is pushes down to the cylinder. Also the liquid is at rest, that is, the net force on that liquid column is 0. If this force is acts in downward direction, the cylinder goes down, but this is not happen, liquid cannot flow. Therefore, some force which is present, which is push this cylinder in upward direction. I will draw this force here. This force pushes the cylinder in upward direction. Also, the weight of this cylinder is acting downward direction. This is the gravitational force. Therefore, there are three forces I will draw here. The first force, this is downward force, gravitational force downward, and this is upward force. Since the cylinder is equilibrium, it cannot move. Therefore, at equilibrium, total upward force is equal to total downward force. And you know that pressure is equal to force upon area. Therefore, force is equal to pressure into area. I can say this pressure is suppose P2, this is P1. Therefore, upward force, this is force. Here pressure is P2 and area is A. Therefore, P2A is upward force. And what is the downward force? P1A plus mg. This is the downward force. Okay. Also, mass of that fluid in that cylinder is equal to density into volume. Okay. And therefore, I will replace here m by rho into A into H into G. Therefore, P2A is equal to P1A plus this is m and this is G. A get cancelled out. Therefore, P2 is equal to P1 plus H rho G. Okay. Now we have to discuss some definitions. What is mean by absolute pressure? Absolute pressure means the pressure at a particular point in that fluid is known as absolute pressure. Okay. Pressure at particular point inside the fluid is known as absolute pressure. In that absolute pressure, we have to consider, suppose this is atmosphere here is present, then the atmospheric pressure plus this pressure plus this pressure. That is absolute pressure means total pressure at a particular point. Now the second is atmospheric pressure. Atmospheric pressure means we know that the air envelope is present about 400 km from the earth's surface. Therefore, this air exerts a normal force on each normal force per unit area. Okay. Suppose there is a free surface of liquid, then the pressure